So hello students, today discussion is about oxygen. So students, oxygen symbol is O, its atomic number 8. So many students have this doubt, the difference between oxygen and oxygen gas. Oxygen is an element, oxygen gas is a molecule of element. That means students, when two oxygens combine, they produce a molecule called as O2. So in this chapter, our discussion is about O2, its chemical properties, physical properties and all the behavior of oxygen. So we'll discuss in this video. So to start with students, how much percentage that our atmosphere is made with oxygen? 21%, right? So to start our discussion, these are all the main points we'll study, we'll discuss in this video. So first, discovery of oxygen. The first discovery was done by the scientist students Carl William, and he called this gas as fire air. That means he concluded that all the burning happens in the presence of this oxygen. So he called this gas as fire air, but he was unable to explain the elemental character of oxygen. Later on, Joseph Priestley, he also discovered independently oxygen, and he called this air as dephlogisticated air or active air, which the meaning is combustible air. Active air means reactive air, but he didn't explain the elemental character of oxygen. But later on, Lavoisier explained that oxygen is an element, and he named this element as oxygen. Oxy means acid, gen means generator, that means acid former. So he believed that almost all the acids are made up of oxygen only, but which is not correct, but the name remains as oxygen. So this is what the little history behind the oxygen and its name. Next, occurrence of oxygen. Occurrence means like where does this oxygen available in the nature? So mostly students, oxygen is available in water, right? In the free state means you already know 21% is made up of oxygen gas O2, where two oxygen atoms combined. And in water also students, what is the formula of water? H2O, right? H2 is made up of two hydrogen atoms and one oxygen atom. So is an element, water molecule is made up of oxygen as well as oxygen gas also present in the water in the dissolved state, right? So oxygen gas dissolves in water. Almost how much? 0.89% of oxygen is available in this water, in the dissolved state, as well as major share of oxygen is coming from the minerals. Minerals means all these metals, non-metals. How they are available in the nature? They are available in the nature in their oxide form, like aluminium oxide, magnesium oxide, calcium oxide, phosphorus oxide, yes or no? Phosphorus pentoxide, carbon dioxide, carbon monoxide. So all these sulfur dioxide. So all these metals and non-metals available in the nature in the combined form, and these combined forms are called as minerals. So mainly oxide form as well as other minerals like carbonates, phosphates, nitrates. What are carbonates? CO3 minus 2 is a carbonate. What is phosphate? PO4 minus 3 is phosphate. So major portion, how much students? Almost like 50% of the oxygen available in the combined form, in the form of minerals. That makes oxygen one of the most abundant element on this planet Earth, including all this combined form with the minerals. So now, what is its position in the periodic table? So oxygen family belongs to the 16th group students, along with the other elements like oxygen, sulfur, selenium, tellurium, polonium, and this oxygen family is also called as chalcogens. Chalcogens, right? Calc means copper, gen means generators. These group elements generates copper. They are the copper producers. How it is possible? Copper is a D block element, right students? But how these are the P block elements. How these elements can generate copper? They generating copper means students not by synthesizing, not by chemical reaction. They do not come, not by nuclear reactions also. Copper is one of the ancient element. That means from the ancient times copper is in use, yes or no? But how the copper available in the nature? Is it available in the free form, in the free state? No. Copper available in the nature in the oxide form, sulfide form, or in the selenium or tellurium forms also very rarely. That means copper mostly available in the nature by combining with 16th group elements only. So while refining copper, while extracting copper, from which group are we extracting? From the chalcogens only. That means 16th group elements only. That's why these group elements are named as chalcogens. Calc means copper generators. How they are generating copper? Copper already exists in the nature. By combining with these group elements, simply we are separating, we are refining copper from these group elements. That's how they got their name. Next, allotropes of oxygen. Allotropes means, students, the same element that can exist in different forms, different physical forms are called as allotropes. So oxygen, mostly dioxygen, O2, that is the most how it is available, as well as ozone form also. Oxygen is also available in the form of ozone, which is O3. How O3 forms, students? In the presence of UV light, ultraviolet light coming from the sun rays, oxygen gas can be converted into ozone, which is O3. So you already know this O3 or ozone saves us from these harmful radiations coming from the sun. As well as, have you heard about depletion of ozone layer? That happens because of chlorofluorocarbons, which mainly made up of carbon monoxide. The carbon monoxide, when it reaches to the ozone, it reacts with ozone. That means CO plus O3 gives rise to CO2 plus O2. Again, ozone converts into oxygen gas. This is nothing but the depletion of ozone layer. So these are the allotropes, mainly oxygen, dioxygen, as well as this is also called as trioxygen, which is ozone. Next, isotopes of oxygen. So students, answer. What are isotopes? Define isotopes. Isotopes means atoms of elements with same atomic number but different mass number are called as isotopes. So what are the famous isotopes of oxygen? O16, O17, O18. O16. So what is the atomic number of oxygen? 8. It contains how many protons? 8 protons, 8 electrons and 8 neutrons. Next, O17. How many protons? 8 protons, 8 electrons but 9 neutrons. One excess neutron is present. O18, how many neutrons? 10 neutrons. So, but in all these three isotopes, which is the highly abundant, students? O16 is highly abundant. That means we are talking about water. Water contains oxygen. That oxygen, whether it is O16 or O17 or O18, that oxygen is made up of O16 only, most abundant. So, the whole discussion about oxygen is about O16 isotope only. Remaining are also available, but very rarely they are formed. So why these isotopes are the reason? Because of the presence of excess neutrons. Students, right? Clear about isotopes also. Next, preparations of oxygen gas. So mainly we have the first reaction, that is electrolysis of water. So what is electrolysis of water, students? Water by decomposition in the presence of electricity. How water will be decomposed? Water is decomposed into H plus ions and OH minus ions. Yes or no? Later on, H plus and oxide ions, O minus 2 ions. These H plus ions will be deposited at cathode and O negative ions, O minus 2 ions will be deposited at anode. H plus ions, gains electrons and they produce hydrogen gas, and O negative 2 ions loses electrons and they produce oxygen gas at anode. So we can synthesize oxygen gas from water. Why? Because water is made up of hydrogen and oxygen in the presence of electricity. This is called as electrolysis or electrolysis technique. Next, by heating some of the metallic oxides, right? Metallic oxides contain oxygen. If you heat these metallic oxides, thermal decomposition, so they can also be separated to form the metal and oxygen gas. For example, look at mercury oxide, HGO. So it is almost red in color. By thermal decomposition, you can see the temperature range at around 450 degrees Celsius. This molecule decomposed into mercury and oxygen gas. Here color changes are very, very important, that you have to remember. So silver color mercury, which is more of black tint because of the high temperature. So red in color converts into black tint, silverish mercury will be produced, and as well as oxygen gas is also released. Next, silver oxide. Silver oxide is brown in color, students. By decomposition process, it converts into silver color, which is pure mercury, as well as oxygen gas is released. Next, reddish orange lead oxide converts into yellow color lead monoxide and oxygen gas is released. So all these reaction comes under thermal decomposition reaction. This electrolysis of water comes under electrolytic decomposition reaction. Ultimately, we can synthesize oxygen by the decomposition reactions. Next, physical properties of oxygen. Physical properties means what? Color, taste, all come to melting point, boiling point, solubilities comes under physical properties. First, nature. Oxygen is a colorless, tasteless and odorless gas, right? Simple. Density. Density, like oxygen gas is slightly heavier than air. What is density, students? Mass per unit volume is called as density. That means number of molecules in unit space is called as density. So you have to remember the point that oxygen is slightly heavier than air. Next, solubility. Oxygen is sparingly soluble in water. Sparingly soluble means what, students? By by constant titrations we can soluble more of oxygen into the water. So and its solubility decreases with increase of temperature. Yes or no? For example, take 2 glasses of water, and try to heat 1 glass of water. Now we have the normal water and some warm water. So where there is more oxygen present, in the normal glass of water or some warm water? In normal water only. Why? Because when you try to heat the water, the oxygen which is already dissolved in the glass will escape into the air because of more temperature. Temperature will be gained by the gas, right, students? So that's why if you increase more temperature, solubility, what happens? It decreases. So that's the point. Next, boiling points and melting point. These are the temperature ranges. Next, this point is very, very important. Oxygen liquefies on cooling to form a pale blue liquid, which is commonly called as LOX. LOX means liquefied oxygen. Mainly it is used in the space rocket industry as a fuel. Next, these are the physical properties of oxygen, students. Now we have to discuss the chemical properties of oxygen. So look at here, combustibility. So oxygen is a non-combustible gas, but it supports combustion. What's the meaning? That means if you try to burn oxygen, it doesn't undergo combustion, but it makes other compounds or elements undergo combustion in the presence of oxygen. For example, burning carbon, how does it take place? In the presence of oxygen, carbon converts into carbon dioxide or carbon monoxide, insufficient of oxygen. Burning magnesium, what it converts into? Magnesium oxide. So what is happening here? All the burning reactions takes place in the presence of oxygen. So that's what the meaning. The point says it supports combustion. So combustion means burning reaction, students. So when a glowing splinter is taken in the jar of oxygen, it rekindles, right? So next, action with litmus. Oxygen is a neutral towards the litmus. It is neither acidic or basic in nature. It's a neutral substance. Oxidizing property, like I said. So if you try to burn all these elements, they form their respective oxide. That means it makes other elements to undergo oxidation. So that's why it is a good oxidizing agent. So but exceptions are very important, students. Gold, silver, platinum. These metals, they will not react with the oxygen. So that's why they do not form any kind of corrosion layer with oxygen. Silver forms, but that is silver sulfide. So platinum and gold, mostly they are least reactive elements, so that they do not react with oxygen. Next, we have some oxidation reactions of metals, students. Metals means we already know what are metals. How can we define metals? Elements which are lustrous, malleable, ductile, sonorous, these are metals. Chemical reactive, chemical definition, what are metals? Elements which have more electropositive character are called as metals. That means elements which have a tendency to lose electrons are called as metals. So look at here, the reaction with potassium, the reaction with sodium. So what happens? Potassium valency is 1, K plus. Oxygen valency is -2. So what is the formula we can expect? K2O, potassium oxide. Sodium also same, Na2O. So these are all the compounds which are produced after the reaction with oxygen. That means most of these reactions are burning reactions only, and they produces the respective oxides. Here also the main important one is color. So what is the color of flame with potassium? Lilac flame. That means the color is like pinkish purple color flame. As well as this, for sodium it is golden yellowish in color. And as well as litmus paper, you have to remember here one statement, that is all the metallic oxides are basic in nature, students, and all the non-metallic oxides are acidic in nature. Now answer, in the presence of litmus, what is the color change for base? The color change for base is red to blue in color. For acids, opposite, blue to red in color. So these are all the basic oxides, right? So what is the color change we can expect? Red to blue, and as well as red to blue color. With calcium also same, calcium valency is 2. So +2 -2, what is the, they combine in 1:1 ratio. Calcium oxide, brick red color, the color of the flame, and as well as metallic oxides are basic oxides, red to blue in color. Magnesium oxides, dazzling white color, and red to light blue in color. So these are all the bases. Metallic oxides are all basic in nature. In presence of oxygen, by burning, they produce the respective metallic oxides. So next action, oxidation of non-metals. See how metals converts into metallic oxides. Non-metals also converted into non-metallic oxides, but they are acidic in nature. So action with hydrogen. So here hydrogen, students. Hydrogen, when they react with oxygen under high temperature, this flame we already discussed in another chapter. The flame is called as hydrogen flame, which can be maintained at around the temperature 2800 degrees Celsius, which is used for welding purposes, right students? So hydrogen also can be combined with oxygen to produce H2O. Now answer, H2, is it an acid or a base? H2O is neither acid nor a base. H2O is neutral substance, students. Why? Because H2O can release H plus ions as well as OH minus ions. So it is neutral towards the litmus paper. And what's the color of flame? Very pale bluish in color. You have to remember all the flame colors. Next, action with nitrogen. So nitrogen combines with oxygen and it produces the respective nitric oxide as well as nitrous oxide, nitrogen dioxide. All the components are produced, can be performed. And mostly here the general is nitric oxide, which is NO. And action with carbon plus O2. C plus O2 gives rise to CO2, bright yellowish in color. And CO2, is it acidic or basic or neutral? This is acidic. Why? Because non-metallic oxide, so blue to red color. Sulfur, action with sulfur. Sulfur reacts with oxygen, that means burning of sulfur. It produces sulfur dioxides and the respective sulfur trioxides also. So the color of flame is bluish in color and the color change is blue to red color, students. So metallic oxides are basic in nature, non-metallic oxides are acidic in nature. That's the point to be noted here. Next, action with hydrocarbons. These reactions are very, very important reactions. Why? Because look at the reactants here: methane, ethane, here it is ethene, propane, butane, octane, hexane. What are all these compounds? They are called as hydrocarbons, students. They are also called as fossil fuels, petroleum products. Where do we use all these chemicals in our daily life? As an energy source, as a fuel. We are burning all these chemicals as a fuel for the energy source, students. So while burning any hydrocarbon, the common products we can expect are carbon dioxide and water molecules. So these are also the combustion reactions and exothermic reactions. They release high amounts of energy which we utilize for all the energy needs. So these gases, these are also called as fossil fuels or petroleum products. Very, very important. We have a separate discussion about these compounds called as organic chemistry. So next, uses of oxygen. So let's see some of the uses of oxygen. Oxygen means oxygen gas, O2. So astronauts in space, yes or no? Oxygen cylinders they carry. Why? Because there is no oxygen for breathing and all. Next, divers and submarines underwater also. So ultimately for breathing they use oxygen cylinders. Miners during deep mining. Under the deep mining means under the earth crust to at very high temperature ranges, there is less oxygen present under the earth. So they use these cylinders, oxygen cylinders also. Climbers during the high altitude climb. Higher places, students, the gases are very least available. So they carry these oxygen cylinders. Next, liquid oxygen under the trade name, this we already discussed, LOX, is used to burn the rocket fuel in space. This is most important example. Next, medical uses. Medical uses means mostly in the medical industry. Carbogen is a mixture of 5% of carbon dioxide, CO2, and 95% of oxygen. Where it is used, it stimulates the natural breathing. So the one who suffers all these kind of drowning or gas poisoning, this mixture of carbon dioxide and oxygen was given and it stimulates the natural breathing. So in the medical industry, that mixture is called as carbogen. This point also very, very important. Next, anesthesia, where anesthesia is used to relieve the pain. So what it's a mixture of nitrous oxide. What's the formula of nitrous oxide? N2O. N2 is also called as laughing gas, students. So nitrous oxide as well as oxygen. The mixture of these two chemicals, it is used in the anesthesia in the medical industry under surgical operations also. So that's it, student. These are all the main points about oxygen. So the physical properties, chemical reactions, its discovery, occurrence, allotropes, isotopes, all the points, uses. So decomposition reactions, oxidizing properties, very, very important element. Oxygen is one of the essential element for life. So student, that's all about this chapter. So in the next video, we'll come up with another chapter. Thank you, students.